Welcome back. I'm glad you've returned to the silence. We leave the familiar behind to witness the silent beauty of the cosmos as we begin our long, drifting journey toward Pluto, the lonely sentinel of the solar system's edge, where a heart of solid ice beats in the absolute quiet of the deep dark. For billions of years, this small world has moved through the outer cold, a realm so distant that the sun appears as nothing more than an exceptionally bright star in the permanent twilight. As we approach this distant sphere, the shadows begin to separate into vast plains of frozen nitrogen, towering mountain ranges made of water ice, and a complex network of companion moons that dance in perfect harmony. It is a world that completely challenges our understanding of planetary geology, showing us that even at the coldest fringes of our neighborhood, nature finds a way to reshape the land. We find ourselves floating above a landscape that is both ancient and remarkably young, a place where the passage of time is measured not by days, but by the slow, majestic breathing of nitrogen glaciers. Looking down at the surface, our eyes are naturally drawn to the massive, bright feature that resembles a glowing heart, a feature known to science as tombo regio, which serves as the true frozen pulse of this dwarf planet. This great expanse of ice is not static or dead, but rather a dynamic sea of nitrogen, methane, and carbon monoxide that slowly churns from the faint warmth deep within the core. Above this frozen sea, a delicate blue atmosphere rises gently into space, composed of multiple layers of haze that scatter the faint sunlight and create a ghostly, beautiful ring around the planet. We can almost feel the profound stillness of this atmosphere, which expands and contracts as Pluto moves along its highly oval path around the distant sun. It is a fragile shield, a thin veil of gas that protects a world of unexpected wonders from the harsh emptiness of interstellar space. How strange it is to think that so far from any source of heat, a world could possess such a complex, active, and beautiful sky. Surrounding this icy heart is a unique family of 5 moons, led by the giant Charon, a companion so large that the two worlds are locked in an eternal, face-to-face embrace. They revolve around a hidden point in the empty space between them, a cosmic waltz where neither partner ever shows its back to the other, moving together as a double planet system. Beyond Charon, the smaller moons Nix, Hydra, Kerberos, and Styx spin in chaotic rhythms, tumbling through the darkness like broken pieces of ancient cosmic diamonds. This intricate orbital system acts as a miniature solar system of its own, a testament to the violent history and the complex gravity that shapes the outer reaches of our celestial home. As we settle into the steady orbit of this marvelous world, we prepare to explore the many secrets hidden within its frost, tracing the lines of its geology and the mysteries of its origin. Every canyon, every icy plain, and every distant moon tells a story of survival in the deep dark, a story we are now completely ready to hear. Floating at the very edge of our solar neighborhood, this dwarf planet serves as the gateway to the Kuiper Belt, a vast and mysterious realm of icy remnants from the dawn of creation. This region extends far beyond the orbit of the outer giants, filling the cold void with millions of ancient bodies that have remained untouched for billions of years. By studying this quiet world, we are peering directly into the deep past of our celestial family, reading the preserved pages of how planets first began to assemble. It rests in a cosmic twilight where the influence of our parent star begins to fade, acting as a bridge between the familiar worlds we know and the infinite dark of interstellar space. We look out into this kingdom of frost and realize that what once seemed like an empty wasteland is actually a crowded, whispering gallery of ancient history. The sheer distance between this icy sphere and the bright center of our solar system stretches the imagination, averaging nearly 6 billion kilometers of empty space. To understand this profound separation, we can look at the sunlight, which travels at unimaginable speeds, yet takes more than 5 hours to touch the quiet frozen plains. At this immense distance, the sun is shrunk to a tiny point of brilliant white, offering light, but almost no warmth to the resting landscape below. This distance creates an environment of permanent cold, where gases that we breathe as air on Earth turn into solid stone under the cosmic frost. It is a lonely existence at the deep perimeter, a place where the rhythms of the inner solar system feel like a distant, half-forgotten memory. The path this world takes around the sun is not a neat, circular ring like the paths of the inner planets, but rather an elongated, stretched oval that speaks of an ancient, chaotic history. Because of this highly eccentric orbit, the distance between the dwarf planet and the sun changes by billions of kilometers over the course of its long journey. There are rare eras when its path actually brings it closer to the sun than the giant planet Neptune, temporarily shifting its position in the celestial order. During these closer approaches, the hidden warmth causes the frozen surface to slowly breathe, releasing gases that temporarily awaken its thin atmosphere. As it drifts away once more into the deep dark, this brief awakening fades, and the world returns to its long, frozen hibernation. In addition to its stretched path, this distant world travels on a plane that is significantly tilted compared to the flat disk where the major planets reside. It moves at an angle of 17 degrees relative to the main planetary highway, rising high above and then plunging far below the rest of the solar family. This tilted journey means that it views the solar system from a unique perspective, looking down upon the planetary orbits like a solitary watcher from a high balcony. This unusual tilt is likely a scar from an ancient encounter, a sign of gravitational dances with the outer giants during the early days of cosmic formation. It reminds us that the architecture of space is full of beautiful irregularities, where every tilted path tells a story of survival and change. The reclassification of this world as a dwarf planet was not a reduction of its importance, but rather the discovery of an entirely new class of celestial objects that redefine our understanding of space. For many decades, it was thought to be an isolated oddity, a lonely mismatch at the edge of the dark, until modern telescopes revealed a vast family of similar icy worlds sharing its domain. It represents the archetype of the Plutoids, bodies large enough to be shaped into spheres by their own gravity, yet not massive enough to clear their orbital paths of other cosmic debris. This distinction highlights the wonderful complexity of planetary definitions, showing us that nature does not easily fit into our rigid human categories. By embracing its true identity, we open our minds to a much larger solar system, one populated by thousands of hidden gems waiting in the dark. Though it possesses a rich and diverse geological landscape, this world is remarkably small in physical scale, measuring less than 2,400 kilometers across its frozen equator. To place this scale into perspective, its entire diameter is smaller than the width of the United States, and its total surface area could comfortably fit within the borders of the continent of South America. It is even smaller than our own moon, a realization that makes its active geology and complex atmosphere seem even more miraculous to modern science. One might expect such a tiny body to be a cold, dead fragment of rock, completely frozen solid and unchanging through the passing eons. Instead, we find a miniature masterpiece of nature, proving that grandeur in the cosmos is not measured by size alone, but by the complexity of the soul within. Because of its small size and low mass, the pull of gravity on this distant world is incredibly weak, amounting to only about 7% of the gravity we experience on Earth. If a traveler were to walk across these nitrogen glaciers, their body would feel as light as a feather, allowing them to leap high into the hazy sky with the slightest effort. This gentle gravity changes the way landscapes behave, allowing high mountains of water ice to tower into space without collapsing under their own weight. It also means that the fragile atmosphere is held very loosely, extending far into space like a soft, glowing halo, rather than being pulled tightly to the ground. In this low-gravity environment, every movement becomes a slow, drifting ballet, matching the quiet rhythm of the surrounding cosmos. A single journey around the sun takes this world more than 248 Earth years to complete, a cosmic cycle that spans generations of human history. Since its initial discovery by human astronomers in the early 20th century, it has not yet completed even a single full orbit around its parent star. This immense orbital period means that seasons on this world do not change over months, but endure for decades at a time, creating prolonged eras of light and shadow. A person living on this world would never experience a single birthday, as the passage of time is stretched out into a grand, epic scale that transcends our ordinary lives. It teaches us a lesson in deep time, reminding us that the universe moves to a majestic clock that requires patience to truly understand. While its year lasts for centuries, a single day on this world is also significantly longer than our own, requiring over 6 Earth days and 9 hours to complete one rotation on its axis. This slow, deliberate spin means that the long nights are deeply prolonged, wrapping the icy landscapes in darkness for many days at a time. The sun rises with agonizing slowness, crawling across the dark sky like a distant diamond before sinking beneath the sharp, frozen horizon. This leisurely rotation is caused by its deep gravitational connection with its largest moon, which has slowed the planet's spin over billions of years. This creates a peaceful rhythm where there is never any rush, allowing the features of the land to bask in the dim light for a long, undisturbed duration. Even at the peak of high noon, the illumination on this world is incredibly dim, resembling the soft, blue twilight that settles over the Earth just after the sun has set. This specific level of brightness, known to scientists as Pluto time, is still clear enough for a human eye to see, allowing the features of the landscape to be visible in a ghostly, monochromatic beauty. The light is devoid of any burning heat, arriving as a cold illumination that makes the nitrogen glaciers shimmer like fields of fallen snow under a full moon. It is a gentle, resting light that does not pierce the eyes, but rather bathes the entire world in a serene, meditative glow. In this soft twilight, the boundaries between day and night become blurred, creating an everlasting evening that is perfectly suited for a world resting at the edge of the infinite dark. Deep beneath the frozen plains of this distant world lies a hidden interior structured much like a miniature terrestrial planet. Scientists believe that a massive rocky core occupies the center, making up roughly 70% of the planet's total mass. This dense heart of stone is wrapped in a thick, insulating mantle composed entirely of water ice, creating a profound contrast between the rocky deep and the frozen surface. Over the eons, gravity has carefully separated these materials, pulling the heaviest elements inward while allowing the lighter ice to rise and form a protective shell. This layered architecture provides the structural foundation for everything we see above, anchoring the vast fields of shifting frost. It is a quiet reminder that even the smallest worlds possess a complex inner life, hiding secrets of heat and pressure beneath a calm, frozen mask. Within the dark boundary, where the rocky core meets the icy mantle, a wondrous mystery may be hiding from our sight. The slow decay of radioactive elements within the central rocks might generate just enough warmth to maintain a hidden, liquid water ocean. This dark, subterranean sea would be kept liquid despite the unimaginable cold of space, protected by kilometers of overlying ice that act as a thermal blanket. Salts and ammonia dissolved in the water would act as a natural antifreeze, lowering the freezing point and allowing this secret ocean to endure across billions of years. To imagine a liquid realm existing so far from the sun stretches our understanding of where oceans can survive in the cosmos. It suggests that water, the very fluid of life, might be far more common in the dark, outer reaches of space than we ever dared to dream. The true bedrock of this dwarf planet is not made of stone as it is on Earth, but rather of ordinary water, ice frozen to an absolute, unyielding density. In the extreme cold of the outer solar system, water ice behaves exactly like granite, becoming incredibly hard, rigid, and strong enough to support massive geological structures. This frozen bedrock forms the deep crust, carving out profound canyons, jagged valleys, and towering mountain ranges that pierce the thin sky. Without this solid foundation of water ice, the softer, more volatile ices on the surface would simply collapse and flatten out over time. It is a strange inversion of nature, where a substance we think of as fragile and melting becomes the eternal, immovable mountain ranges of a distant world. Resting gently on top of this rigid water ice bedrock is a delicate veneer of volatile ices, which give the world its bright and varied appearance. These superficial layers are composed primarily of nitrogen, methane, and carbon monoxide, substances that exist as gases on warmer worlds, but are trapped here in a solid state. Because these ices are soft and easily manipulated by even the slightest changes in temperature, they flow and shift like slow glaciers across the landscape. They coat the lowlands, fill the basins, and paint the surface in shades of brilliant white, pale pink, and deep crimson. This volatile coating acts as the dynamic canvas of the planet, constantly responding to the slow seasonal rhythms of its long journey around the sun. When we gaze upon the magnificent heart-shaped feature on the surface, our attention is drawn to its vast western half, a colossal plain known as Sputnik Planitia. This immense area is a completely smooth, featureless expanse of nitrogen ice that stretches across more than 1,000 kilometers of the planet's surface. It appears as a brilliant, glowing white sea, reflecting the dim sunlight like a mirror placed in the middle of a dark wilderness. There are no mountains here, no jagged rocks, only a vast and seamless sheet of frozen gas that seems to go on forever into the horizon. This plain is the true geological center of activity, a place where the planet's frozen blood pools and interacts with the surrounding environment in ways that continue to amaze modern science. The origin of this great nitrogen plain is believed to be the result of a cataclysmic event that occurred billions of years ago during the early formation of the solar system. A massive cosmic object, perhaps a giant asteroid or a wandering comet, crashed into the planet with unimaginable force, carving out a profound basin deep into the water ice crust. Over the long eons that followed, this deep depression acted as a natural trap, collecting volatile nitrogen gases that condensed out of the atmosphere and filled the void. The sheer weight of this accumulated ice became so immense that it actually caused the entire planet to tip over, reorienting its spin axis to accommodate the new distribution of mass. This ancient scar of violence has thus been transformed over time into a place of supreme peace, a frozen sanctuary born from a moment of cosmic chaos. One of the most astonishing discoveries made by modern spacecraft is the complete and utter absence of impact craters across the entire expanse of Sputnik Planitia. Throughout the solar system, Ancient surfaces are heavily scarred by meteorites. Yet this vast nitrogen plain remains completely unblemished and smooth. This lack of damage tells scientists that the surface we are looking at is incredibly young, perhaps less than 100 million years old, which is a mere blink of an eye in cosmic time. The plane is constantly renewing itself, erasing the marks of passing meteorites just as fresh snowfall covers the tracks of a traveler on Earth. It proves that this distant world is not a dead, frozen relic of the past, but a living body capable of healing its own wounds through continuous geological activity. If we glide closer to the smooth surface of Sputnik Planitia, we begin to see a mesmerizing pattern of giant polygonal cells covering the ice like a prehistoric mosaic. These shapes, measuring tens of kilometers across, are the surface expressions of a slow, majestic process of thermal convection happening deep within the nitrogen sea. The faint warmth escaping from the planet's rocky core heats the lower layers of nitrogen ice, causing them to expand, become less dense, and slowly rise toward the surface. Once at the top, the ice cools in the absolute chill of space, rolls outward toward the edges of the cells, and sinks back down into the dark depths to repeat the cycle. This incredibly slow churning motion takes millions of years to complete a single turn. A silent, subterranean heartbeat that keeps the surface in a state of eternal motion. The interaction between the frozen ground and the thin atmosphere creates a continuous cycle of sublimation and deposition that reshapes the landscape with every passing season. Nitrogen ice does not melt into a liquid when it absorbs energy from the distant sun, but instead transforms directly into a faint, invisible gas that rises into the sky. This gas drifts across the planet until it reaches colder regions or enters the deep shadow of night, where it falls back to the ground as a delicate, sparkling frost. This endless migration of material strips ice from some areas and piles it high in others, creating a dynamic weather system where the land itself moves through the air. It is a gentle, poetic balance of nature, an ongoing conversation between the solid ground and the sky that ensures the world is never truly still. The striking colors that paint the edges of the icy plains are the result of a slow, complex chemical dance orchestrated by the faint light of distant stars and ultraviolet radiation. When sunlight hits the traces of methane and nitrogen gas in the atmosphere, it breaks apart their molecular bonds, allowing them to recombine into complex organic molecules called tholins. These heavy organic compounds slowly rain down from the sky like a dark, silent dust, coating the ancient water ice mountains in rich hues of dark orange, deep red, and charcoal brown. They gather in the ancient craters and along the coastlines of the nitrogen sea, creating a stark, beautiful contrast with the pristine white of the glaciers. These tholins are the chemical building blocks of worlds, ancient materials that remind us that the ingredients for complexity are scattered even in the coldest corners of the universe. Rising sharply along the western borders of the great nitrogen sea are immense mountain ranges that break the flat monotony of the plains. These colossal structures are composed entirely of hard water ice, acting as rugged barriers against the shifting fields of frozen gas. When we look closely at the boundary where the mountains meet the smooth plain, we see a dramatic intersection of deep shadows and brilliant reflections. It is here that the true physical diversity of the planet reveals itself, showcasing a landscape split between flat horizons and jagged, soaring peaks. This mountainous terrain stands as clear proof that the crust has experienced profound mechanical stress, pushing the rigid bedrock high into the thin sky. The stark contrast between the bright plains and the dark slopes creates a stunning visual boundary that defines the complex geography of this distant world. Among these ancient peaks, the majestic range known as Tenzing Montes towers over the landscape, reaching heights of several kilometers above the frozen floor. These mountains rival the grandest ranges on Earth, yet they are formed in an environment of unimaginable cold, and from materials we usually associate with delicate frost. Because water ice is significantly less dense than the solid nitrogen plains that surround it, these massive mountains essentially behave like colossal icebergs trapped in a frozen sea. They are anchored deep within the planet's crust, sustained by the low gravity, which allows such massive structures to remain upright without collapsing under their own weight. To witness these soaring, frozen giants is to realize that the outer solar system possesses a topography every bit as dramatic as the rocky worlds closer to the sun. They stand as a testament to the unexpected power of ice, carving out a monumental legacy in the silence of the outer rim. Slightly further to the north, the sharp peaks of Hillary Montes rise with an equally impressive grandeur, casting long, dramatic shadows across the edge of the smooth plains. This distinct range exhibits a heavily fractured and jagged appearance, suggesting that it has remained largely undisturbed by any form of traditional atmospheric erosion. Without liquid water or thick winds to smooth their rough edges, these mountains preserve the raw, violent history of their creation perfectly across millions of eons. They stand as silent sentinels of the deep dark, their steep slopes coated in a fine dust of methane frost that sparkles under the faint light of distant stars. The preservation of such sharp, unyielding features offers planetary scientists a perfect, pristine window into the ancient tectonic forces that once tore this world apart. Each jagged ridge tells a story of a dynamic past, frozen in time at the absolute limits of our solar system. As we trace the valleys that wind between these immense water ice mountains, we can observe clear evidence of ancient glacial movement carved into the terrain. Soft nitrogen ice from the central plains appears to have spilled backward into these mountain passes, flowing like a slow, frozen river through the rocky canyons. The patterns of these flows are preserved in exquisite detail, showing smooth curves and dark streaks where the moving frost has scraped against the hard water ice walls. This process mirrors the behavior of alpine glaciers on Earth, yet it occurs at temperatures near absolute zero, using gases as the liquid medium. It is a mesmerizing sight that reminds us how the laws of fluid dynamics operate across the universe, turning frozen gases into slow artists of the landscape. These frozen pathways show us that the surface is constantly interacting, shaping new corridors through the ancient bedrock. A closer inspection of the outer margins of Sputnik Planitia reveals a series of smaller, isolated hills that appear to be completely surrounded by the nitrogen ice sheet. Scientific analysis suggests that these hills are actually giant fragments of water ice bedrock that have broken off from the main mountain ranges and are now drifting through the denser nitrogen matrix. They behave like planetary icebergs, slowly bobbing and shifting over immense periods of time as the convective cells of the plane churn beneath them. These floating blocks can accumulate in vast clusters along the coastlines, forming chaotic, jumbled terrains that look like a frozen jigsaw puzzle left incomplete. This unique phenomenon beautifully demonstrates the fluid, dynamic nature of the surface, where even entire hills are not permanent fixtures, but wanderers in a slow-motion sea. It challenges our traditional view of land as something static, replacing it with a fluid world of drifting mountains. Beyond the immediate borders of the Great Heart, the landscape is heavily scarred by an extensive network of deep faults and elongated troughs that stretch for hundreds of kilometers across the crust. These tectonic features indicate that the dwarf planet has undergone significant periods of global expansion, causing the rigid outer shell to pull apart and crack open. The resulting canyons are incredibly deep and wide, creating massive chasms that plunge down into the hidden layers of the upper mantle. As we peer into these dark fractures, we are looking at the literal structural ribs of the world, exposed by the internal forces that have shaped its history. How remarkable it is that a body so small and cold could possess enough internal energy to fracture its own bedrock on such a grand, global scale. These deep scars reveal a restless nature, showing that the planet's history is written in the deep lines of its broken crust. Perhaps the most enigmatic geological features on this entire world are the massive, rounded mounds located to the south of the Great Icy Plain, exemplified by the colossal structure known as Right Mons. This enormous mountain stretches over 150 kilometers wide and rises several kilometers into the air, presenting a bizarre, hummocky texture that resembles nothing else in the solar system. At its absolute summit lies a profound, deep depression that plunges far below the surrounding peaks, immediately evoking the appearance of a massive volcanic caldera. However, this is not a volcano born of molten rock and burning fire, but rather a cryovolcano, a monument to the power of ice. It represents a completely different kind of planetary activity, where the cold itself becomes the driving engine of volcanic creation. This giant structure forces us to reconsider what is possible on a world so far removed from any significant source of traditional heat. The mechanism behind these icy eruptions involves a fascinating slurry of liquid water, ammonia, and various volatile ices migrating upward from the deep interior. Under the immense pressure of the crust, this freezing mixture behaves much like magma on Earth, slowly oozing through fractures until it breaches the surface. Upon entering the absolute vacuum and cold of space, the liquid slurry does not explode violently, but instead spreads out in thick, viscous waves that solidify almost instantly. Over countless generations of eruptions, these successive layers of frozen material build up the massive domes and undulating terrains we observe today. This process reveals that the interior of the planet must have retained a surprising amount of warmth, allowing liquid mixtures to remain mobile long after the world was thought to have frozen solid. It is a slow, quiet form of volcanism, painting the surface with the liquid secrets of the deep interior. Even larger than its nearby neighbor is the immense feature known as Pickard Mons, another candidate for a massive cryovolcanic complex that dominates the southern skies. This towering structure is shrouded in deep shadows and heavily coated with dark, complex organic molecules that have settled out of the hazy atmosphere. The slopes of this giant mound are creased with complex concentric fractures, suggesting that the entire mountain has experienced multiple episodes of inflation and collapse over its long lifetime. It sits like a silent titan at the edge of the world, a monument to an era when the interior was active enough to reshape the topography on a truly grand scale. The sheer volume of material erupted by this feature forces us to rethink our models of how small planetary bodies conserve their primordial heat. It looms large in the twilight, a dark masterpiece of icy geology that guards the secrets of the planet's evolution. The existence of these massive water ice mountains and active cryovolcanoes challenges the long-held scientific assumption that small outer worlds must be geologically dead. Traditional theories suggested that a body of this size would lose its internal heat within the first billion years of its existence, leaving behind a cold, unchanging sphere. Instead, the rich topography and youthful plains we observe prove that some hidden mechanism continues to power the planet from within, keeping it alive and active across deep time. Whether this heat is maintained by the slow freezing of a subterranean ocean or by the radioactive decay of elements in the core, it shows that the cosmos is full of delightful surprises. We are left contemplating a world that defies expectations, a vibrant testament to the enduring power of planetary geology in the farthest reaches of the dark. It reminds us that even in the deepest freeze, the spirit of activity can endure, shaping worlds in ways we are only beginning to comprehend. As we turn our gaze upward from the frozen mountains, we encounter the incredibly delicate atmosphere that envelopes this world like a spectral blue shroud. This thin veil is composed primarily of molecular nitrogen gas, which is the exact same substance that dominates the air we breathe on Earth. However, the atmospheric pressure here is incredibly low, amounting to only a tiny fraction of our home planet's pressure, making it thinner than the highest reaches of Earth's stratosphere. It exists in a state of fragile balance, completely dependent on the temperature of the solid nitrogen glaciers resting on the ground below. This ethereal sky acts as a bridge between the solid world and the infinite vacuum of space, a silent testament to the planet's ability to retain its volatile soul. Suspended within this thin sky is a breathtaking structure of global haze layers that extend for many hundreds of kilometers above the surface. These hazes are not a single, uniform cloud, but are rather arranged in dozens of distinct, concentric layers that wrap the world in a beautifully organized pattern. They are visible as a brilliant blue ring when the dwarf planet passes in front of the distant sun, scattering the light in a display of cosmic artistry. These layers are formed by the interaction of sunlight with atmospheric gases, creating tiny particles that slowly settle down toward the frozen ground. This complex atmospheric architecture creates a soft, diffused light that filters down to the plains, softening the sharp edges of the deep dark. The striking blue color of this atmospheric ring is caused by a scientific phenomenon that mirrors the behavior of our own sky on Earth. When the faint ultraviolet light from the sun reaches the upper atmosphere, it interacts with tiny organic particles called thalin precursors, which are suspended in the gas. These particles are exactly the right size to scatter the shorter, bluer wavelengths of light, while allowing the redder wavelengths to pass through unhindered. If a traveler were to stand on the nitrogen glaciers and look up during the local twilight, they would see a beautiful, dusky blue sky rather than the stark blackness of open space. This shared characteristic with Earth reminds us that the fundamental laws of optics operate uniformly across the universe, creating familiar beauty in the most distant places. Because the dwarf planet travels along a highly elongated and stretched orbital path, its atmosphere undergoes a dramatic cycle of global expansion and collapse. As its journey brings it closer to the distant sun, the slight increase in warmth causes the frozen nitrogen on the surface to sublimate directly into gas, causing the atmosphere to swell and grow significantly thicker. Conversely, as the world retreats back into the deep dark of the outer solar system, the extreme cold causes the atmospheric gases to freeze out and fall back to the ground as a delicate global snowfall. This grand atmospheric heartbeat spans over 2 centuries, a slow and majestic breathing pattern that defines the long climate cycles of the world. It shows us an atmosphere that is not permanent, but rather a temporary gift of the sun that appears and disappears over the eons. Despite the extreme thinness of the air, the atmosphere extends remarkably far into space, reaching altitudes that are significantly higher relative to the planet's size than the atmospheres of larger worlds. This immense extension is a direct result of the planet's weak gravitational pull, which lacks the strength to compress the gases tightly against the frozen surface. The upper boundaries of the sky gently blend with the solar wind, creating a long, trailing tail of escaping nitrogen ions that drifts through the cosmic dark. This vast atmospheric envelope means that the planet is much larger when viewed in ultraviolet light than it appears in visible light, wrapped in a giant, invisible bubble of gas. It hovers in the vacuum like a soft, protective halo, a fragile barrier that speaks of the delicate balance between gravity and thermal energy. Within this quiet atmosphere lies a surprising meteorological paradox known as a temperature inversion, where the air actually becomes significantly warmer as you rise higher above the ground, while the surface itself is locked in an absolute freeze near the floor of cosmic temperatures. The upper layers of the sky are warmed by a thin layer of methane gas. This methane absorbs the faint infrared sunlight, trapping heat and raising the atmospheric temperature by dozens of degrees compared to the frozen glaciers below. This creates a stable, layered sky that suppresses violent storms and allows the distinct haze rings to remain undisturbed for long periods of time. It is a wonderful example of how planetary atmospheres can organize themselves into unexpected patterns, hiding pockets of relative warmth above a world of perpetual ice. The continuous interaction between the thin atmosphere and the volatile surface gives rise to bizarre, sculpted landscapes known as sublimation pits and icy spikes. Across vast fields of nitrogen and methane frost, the light of the sun causes the ice to vaporize unevenly, carving out millions of tiny, elongated depressions that look like cell networks from above. In some high-altitude regions, this process creates towering blades of ice known as penitents, which stand several meters tall and point directly toward the distant sun like a field of frozen swords. These structures are formed across decades of slow evaporation, a quiet and meticulous sculpting process that requires a delicate atmosphere to occur. They show us that weather on this world does not require rushing winds or pouring rain, but can manifest as a slow, silent transformation of the solid ground itself. Despite the incredibly low density of the atmospheric gas, modern science has discovered undeniable evidence of real winds blowing across the smooth plains of Sputnik Planitia. These gentle currents are driven by the temperature differences between the bright, reflective nitrogen ice and the dark, thawing-covered mountain ranges that border the sea. Over long periods of time, these winds are strong enough to carry tiny grains of solid methane sand across the surface, depositing them in long, regular ripples. These frozen dunes stretch across the landscape in perfect geometric alignment, creating a mesmerizing pattern that mirrors the sand deserts of Earth or Mars. It is a stunning realization that an atmosphere so thin can still possess the mechanical power to reshape the land, proving that the wind is an active sculptor even at the solar system's edge. The global circulation of this thin atmosphere is governed by a majestic, planet-wide wind pattern that blows in a direction opposite to the world's natural rotation. This phenomenon, known as a retrograde wind system, is driven by the continuous sublimation of nitrogen ice at the bright, sunlit heart of Sputnik Planitia. As the ice turns to gas, it creates a localized high-pressure zone that pushes the air outward, forcing it to rush across the dark equator and around the globe. This gentle, continuous breeze acts as a global conveyor belt, transporting volatile gases and organic hazes across thousands of kilometers of terrain. It ensures that the entire world remains climatically connected, sharing its atmospheric composition across both the illuminated plains and the deep dark of the night hemisphere. For many years, scientists worried that this delicate atmosphere would escape into the vacuum of space very rapidly, eventually leaving the world completely bare and airless. However, modern measurements have revealed that the rate of atmospheric loss is remarkably slow, meaning the planet is able to preserve its beautiful sky for billions of years. The cold temperatures of the upper haze layers act as a natural brake, slowing down the molecules and preventing them from reaching escape velocity too easily. This long-term stability allows the complex chemical reactions that produce the red tholins and blue hazes to continue uninterrupted across cosmic time. It tells us a story of endurance, showing that even the most fragile things in the universe can find a way to persist against the eroding forces of the great cosmic ocean. Shifting our focus away from the atmospheric veil of the primary world, we encounter its immense companion, Charon, a moon so remarkably large that it completely dominates the local cosmic landscape. Measuring more than half the diameter of the dwarf planet it orbits, it holds the grand distinction of being the largest satellite relative to its parent body anywhere in our known solar system. If we were to place this moon in our own night sky, it would appear several times larger than Earth's moon, creating a breathtaking visual anchor in the permanent twilight. Its massive presence exerts a powerful gravitational influence, turning what would be a simple planetary system into a complex dance of two nearly equal partners. This unique relationship challenges our traditional understanding of moons as mere subordinates, revealing a rare partnership built on shared mass, ancient history, and cosmic balance. Because these two celestial bodies are so closely matched in mass, the invisible point around which they orbit does not lie deep within the primary planet, but rather hangs suspended in the empty space between them. This center of mass, known to astronomers as the barycenter, acts as a silent, invisible axis around which both worlds perform their endless orbital waltz. They do not experience a simple system where one body revolves around another, but instead move together like two dancers holding hands and spinning around a shared center. This profound dynamic officially classifies them as a true binary system, a double dwarf planet drifting through the outer darkness of the Kuiper belt. It is a mesmerizing spectacle of orbital mechanics, demonstrating that gravity can tie two independent worlds into a singular, beautiful cosmic unit that moves in perfect unison. This close gravitational embrace has resulted in a rare phenomenon called mutual tidal locking, where the rotation of both worlds has become perfectly synchronized across deep time. As a consequence of this perpetual bond, the same side of the moon always faces the primary planet, and conversely, the same side of the primary planet always looks back at its companion. If an observer were to stand on the smooth plains of the nitrogen sea, the giant gray moon would hang motionless in the exact same spot in the sky, never rising and never setting. The opposite hemisphere of the planet remains in a state of perpetual solitude, never catching a single glimpse of this massive companion throughout its entire life. This permanent face-to-face gaze creates a profound sense of cosmic intimacy, an eternal connection where neither world ever turns its back on the other as they travel through the dark. When we compare the surface of this giant companion to the primary world, we notice a striking geological contrast that speaks of a completely different evolutionary path. The moon lacks the bright, shimmering fields of volatile nitrogen and methane ice, presenting instead a muted canvas composed primarily of exposed, gray water ice bedrock. Because its gravity is significantly weaker, it was unable to retain the lighter gases over the eons, leaving its ancient crust bare to the harsh environment of space. This creates a surface that is much darker and less reflective, covered in deep craters and rugged fractures that have remained unchanged for billions of years. It tells a story of a world that stripped itself of its softer elements, choosing instead to reveal its hard, resilient skeleton to the outer universe in absolute silence. Despite its generally gray and icy appearance, the northern pole of this massive moon features a stunning, crimson-stained territory known beautifully to science as Mordor Macula. This mysterious dark region is the result of a fascinating interplanetary theft, where the moon captures escaping gases from the primary planet's thin atmosphere. During the long, cold winter nights at the moon's pole, methane gas drifts across the void, becomes trapped by the extreme chill, and freezes solid directly onto the ground. When the faint sunlight finally returns after decades of darkness, ultraviolet radiation processes this frozen methane, transforming it into the same complex, reddish organic molecules called tholins. This poetic exchange shows us that these two worlds are chemically connected across the empty space, sharing their materials to paint the landscape in unexpected, brilliant colors. Splitting the equator of this giant moon is an absolutely immense network of canyons and chasms that leaves a profound scar across its entire visible hemisphere. This colossal valley system, known as Serenity Chasma, is significantly longer and deeper than the famous Grand Canyon on Earth, representing a truly spectacular feat of planetary tectonics. The existence of such a massive fracture indicates that the moon experienced a dramatic period of internal expansion early in its history. Scientists believe that a deep, internal liquid ocean began to freeze solid, expanding in volume and forcing the rigid outer crust to split wide open like a cracked shell. This deep chasm remains as a silent, permanent monument to the incredible pressures that once warped the moon from within, showcasing a violent past frozen in time at the absolute edge of the solar system. The topography of this companion world is clearly divided into two distinctly different geological terrains that meet along the line of the Great Equatorial Chasm. To the north lies a chaotic, heavily cratered highland region known as Oz Terra, which represents the ancient, battered crust from the dawn of the solar system. To the south, the landscape transitions into a much smoother, flatter plain called Vulcan Planitia, which is remarkably devoid of deep impact scars. This southern plain is believed to have been completely resurfaced by ancient cryovolcanic activity, where vast flows of liquid water and ammonia oozed from the interior to cover the old craters. This clear division tells us that the moon was once a vibrant, geologically active place, capable of healing its southern plains while preserving its northern history for us to study. Unlike its primary partner, which boasts a delicate blue sky and shifting haze layers, this giant moon possesses no true atmosphere to shield its frozen plains. With its low mass and weak gravitational pull, any gases released from its interior or captured from space escape almost immediately into the infinite vacuum. This lack of an atmospheric blanket means that the sky above the gray landscape is always an absolute, pitch-black void, even during the peak of local daylight. There are no winds to move the frost, no hazes to scatter the faint light of the sun, and no weather to erase the ancient marks of time. It exists in a state of perfect, undisturbed preservation, an open museum of cosmic history exposed directly to the raw, unfiltered environment of the outer rim. The origin of this remarkable double planet system is widely believed to be the result of a colossal impact that occurred during the violent infancy of our solar family. Two massive, independent icy bodies traveling through the primordial Kuiper belt collided with each other in an event of unimaginable destructive power. Rather than completely destroying both objects, The energy of the crash allowed a significant portion of the debris to coalesce into the primary dwarf planet we know today. The remaining fragments gathered in a close, swirling ring of dust and ice, eventually merging together to form the giant companion moon that stands beside it. This violent birth explains their closely matched sizes and similar orbital planes, showing that their modern harmony was forged in a crucible of ancient cosmic chaos that reshaped the outer reaches. The complex gravitational dance between these two primary partners creates a unique stability zone that allows 4 smaller moons to survive in the outer suburbs of the system. These tiny satellites revolve around the shared barycenter at immense distances, their paths perfectly aligned with the equator of the central binary pair. Their orbits are locked in a loose mathematical harmony, a beautiful orbital resonance that prevents them from colliding or being thrown out into the deep void. This configuration transforms the entire environment into a fully realized miniature solar system, where the double planet acts as the central sun for its smaller companions. As we watch this intricate clockwork mechanism move through the deep dark, we appreciate the wonderful order that gravity can bring to the farthest, coldest edges of our celestial home. Beyond the grand waltz of the 2 primary worlds lies a wider, quieter realm populated by 4 tiny satellites that went unnoticed by human eyes for nearly a century. These diminutive companions were discovered not by spacecraft visiting the frozen dark, but by the watchful gaze of the Hubble Space Telescope peering from Earth's orbit during the early years of the 21st century. They appeared as incredibly faint pinpricks of light, drifting slowly against the background of distant stars, revealing that the planetary system was far more crowded than anyone had previously imagined. Their discovery completely transformed our understanding of the outer solar system, proving that small worlds can retain intricate families of satellites even at the edge of interstellar space. They sit like a ring of loyal guardians, moving through the deep dark in perfect silence. The first of these outer companions we encounter as we move outward from the giant moon Charon is the fascinating satellite known to science as Nyx. Named after the ancient goddess of darkness and night, this tiny body possesses a surprisingly bright surface that reflects a significant amount of the faint sunlight. Spacecraft observations have revealed that its icy crust is marked by a prominent reddish crater that stands out starkly against the surrounding white landscape. This subtle coloration suggests that the impactor may have excavated deeper, hidden materials, or that the crash triggered unique chemical reactions on the surface. It drifts through the twilight like a chipped diamond, a small fragment of cosmic history that has survived the long eons in the absolute cold. Floating at the absolute outer edge of this intricate satellite system is Hydra, the largest and most distant of the 4 small companion moons. This distant watcher is wrapped in an incredibly pristine blanket of nearly pure water ice, giving it an exceptionally high reflectivity that rivals the brightness of fresh snow. Because it rests so far from the gravitational disruptions of the inner binary pair, its surface has remained largely undisturbed by external forces, preserving an ancient record of the outer system. Scientists are continually amazed by how clean and bright this ice is, as billions of years of space weathering should have darkened its appearance with cosmic dust. It remains a brilliant beacon in the deep dark, a frozen clean mirror reflecting the loneliness of the Kuiper belt. Positioned in the quiet space between the orbits of Nix and Hydra is the enigmatic and distinctly dark satellite named Kerberos. Unlike its exceptionally bright neighbors, this unusual moon possesses a surface that absorbs most of the faint light that touches it, making it incredibly difficult to detect against the black void of space. Close-up images have revealed that it has a unique, double-lobed shape, closely resembling a giant cosmic peanut formed by two separate bodies that gently collided and stuck together long ago. This elongated, dual structure tells a story of ancient, low-velocity mergers in the early days of the solar system, where fragments of ice joined forces rather than destroying one another. It moves through the twilight like a shadow, a silent reminder that nature can create entirely different characters within the same small family. The smallest and most elusive member of this entire celestial family is the tiny satellite known as Styx, which orbits closest to the central binary pair. This incredibly faint world is so diminutive that its exact dimensions are difficult to measure, though it is estimated to span only a few kilometers across its longest axis. It was discovered during intensive searches designed to ensure a safe pathway for arriving robotic spacecraft, appearing as a ghostly speck in the deep cosmic background. Despite its tiny size, its presence completes a beautiful mathematical chain of orbital paths, showing that every inch of this remote space is finely tuned by the laws of gravity. It glides through the dark like a tiny pebble in a cosmic stream, almost invisible yet essential to the harmony of the entire system. The most extraordinary characteristic of these four small outer moons is their wildly chaotic rotation, which sets them completely apart from almost all other moons in the solar system. Because they live in the fluctuating gravitational field of a double planet system, they are pulled and pushed in multiple directions at the same time as the central worlds spin. Instead of keeping one face permanently turned toward the planet, these tiny satellites tumble unpredictably, spinning rapidly and wobbling on their axes like dying tops. An observer standing on their surfaces would see the giant worlds of the central system and the distant sun rise and set in completely random patterns across the sky. This endless, tumbling dance creates a state of perpetual dynamic motion, a chaotic symphony where the normal rules of day and night are completely undone by the shifting gravity of the deep dark. While their individual rotations are completely chaotic, the paths these small moons take around the central binary system are remarkably stable and neatly organized. Their orbital periods are locked into a complex mathematical relationship known as an orbital resonance, where their movements are synchronized in a beautiful cosmic rhythm. For every orbit that the innermost small moon completes, the outer moons complete precise fractional circles, preventing them from ever colliding with each other or being cast out into the void. This invisible geometric framework acts as a protective web, keeping the four small bodies safely bound to their central parents despite the constant wobbling of their paths. It is a stunning example of how order can emerge from chaos, a silent clockwork mechanism operating flawlessly at the cold perimeter of our solar home. The compositional analysis of these smaller moons reveals that, with the notable exception of the dark Kerberos, they are overwhelmingly made of pristine water ice. This shared chemical makeup strongly reinforces the scientific theory that the entire system was born from a single, catastrophic impact billions of years ago. When the primordial ancestors collided, the fragments that were thrown into the outer ring were composed of the cleaner, lighter water ice from the outer layers of the colliding bodies. This explains why these tiny worlds share a similar bright appearance, serving as frozen pieces of a single ancient puzzle scattered across the outer darkness. Their clean surfaces offer an open window into the composition of the early Kuiper belt, preserved perfectly by the absolute freeze of deep space. Because these small satellites possess so little mass, their internal gravity is far too weak to overcome the structural strength of their ice and compress them into neat spheres. As a result, they all exhibit highly irregular, elongated shapes that resemble rough shards of broken glass or cosmic stones tumbling through the void. They have no smooth horizons or gentle curves, but are instead defined by sharp edges, deep valleys, and jagged ridges that catch the faint light of distant stars in unpredictable ways. This lack of spherical symmetry makes them look more like asteroids than traditional planets, highlighting the fine line that separates different classes of celestial objects. They remind us that in the outer reaches of the solar system, form follows the simple balance between material strength and the gentle pull of mass. This intricate family of small, tumbling moons provides modern astrophysics with an unparalleled natural laboratory for studying how binary star systems behave across the wider universe. Many stars in our galaxy exist in pairs, orbiting each other just like the central double planet system of this distant world. And their planets likely experience the same chaotic gravitational forces. By observing how these four tiny satellites navigate the complex gravity of their dual parents, scientists can predict how planets behave in orbit around distant twin suns light years away. Thus, this small and lonely system at the frozen edge of our neighborhood serves as a profound teacher, offering insights that illuminate the dynamics of the entire cosmos. It stands as a beautiful testament to the interconnectedness of all things, where the movements of a few icy shards can unlock the secrets of the distant stars. The long journey of this dwarf planet is beautifully protected by a cosmic dance it shares with the ice giant Neptune, a gravitational relationship known to astronomy as a mean motion resonance. For every 3 orbits that Neptune completes around the Sun, this outer world completes exactly 2, a precise mathematical harmony that has endured for billions of years. This structured rhythm ensures that even though their paths cross in 3-dimensional space, the 2 worlds never actually come anywhere near each other. It is a stunning example of orbital choreography, where gravity acts not as a disruptive force, but as an invisible guardian maintaining perfect cosmic order. This resonance prevents any catastrophic collisions, allowing the small planet to safely navigate the crowded edges of the outer solar system across deep time. As we explore the invisible forces surrounding this distant sphere, we find a world completely stripped of a global magnetic field. Unlike the Earth, which possesses a churning iron core that generates a protective magnetic shield, the internal layers of this dwarf planet lack the convective motion necessary to create a dynamo. This means that the harsh radiation of the outer space environment bears down directly upon the fragile atmosphere and the frozen surface without any magnetic interference. The absence of this shield allows us to observe a planet in its rawest state, completely exposed to the grand currents of the cosmos. It reminds us that the generation of a magnetic field requires a specific recipe of size, heat, and composition that not all worlds possess. Despite the complete lack of a magnetic shield, the thin atmosphere interacts with the rushing stream of particles from the Sun in a surprisingly complex manner. As the solar wind travels billions of kilometers into the outer cold, it eventually encounters the extended halo of nitrogen gas surrounding the planet. This encounter creates a gentle bowing effect, where the solar wind is slowed and deflected around the planet, shaping a long, trailing tail of ionized gas that stretches far into the dark behind it. This phenomenon behaves much like the ion tail of a giant comet, carrying small amounts of the planet's sky away into the infinite void of the Kuiper belt. It reveals a quiet, continuous conversation between the distant Sun and the icy planet, a gentle erosion that has shaped the world over the eons. The total amount of energy that reaches this distant world from our parent star is incredibly minuscule, amounting to less than 1/1000th of the sunlight received by the Earth. This faint illumination arrives as a cold, scattered energy, incapable of melting the rigid water-ice mountains or causing significant thermal disruption to the deep crust. Yet, this tiny amount of sunlight is the sole engine driving the slow sublimation of the nitrogen glaciers and the formation of the atmospheric hazes. It is a profound lesson in efficiency, demonstrating how nature can use the faintest whispers of solar energy to fuel a dynamic, changing world. We are left to marvel at how such a small amount of light can achieve so much, carving out a complex geology at the freezing limits of the solar system. The surface experiences dramatic variations in temperature between different geological regions, driven entirely by how much light the local terrains can absorb. The brilliant white plains of Sputnik Planitia reflect almost all the incoming sunlight back into space, keeping those nitrogen fields at the absolute coldest temperatures imaginable. In stark contrast, the dark, reddish equatorial regions coated in organic tholins absorb the faint light greedily, warming up by a few crucial degrees compared to the icy plains. This subtle temperature difference creates a global thermal engine, driving the movement of gases from the warmer dark zones to the colder bright zones. It is a delicate balance of heat and shadow, a silent climatic loop that constantly redistributes the volatile elements across the globe. When we examine the overall cratering history of the surface, we see a world clearly divided into two completely different eras of time. The ancient, dark region known as Cthulhu Macula is heavily scarred with deep impact craters, representing a landscape that has remained largely unchanged for 4 billion years. Just next to this ancient wilderness lies the pristine, smooth expanse of the nitrogen sea, which shows no signs of meteorite impacts and is completely renewed by continuous convection. This juxtaposition means that a traveler could step from a surface as old as the solar system itself onto a plane that was refreshed just yesterday in geological terms. It showcases a planet capable of preserving its deepest history while simultaneously birthing entirely new landscapes in the silence of the dark. The surface is constantly subjected to a silent, invisible bombardment of high-energy cosmic rays originating from the distant reaches of our galaxy. These powerful particles easily pierce the thin atmosphere, crashing into the frozen methane and nitrogen molecules locked within the crust. Over millions of years, this continuous subatomic impact breaks the chemical bonds of the simple ices, forcing them to reorganize into more complex structures. This slow, cosmic baking process is what ultimately generates the deep, dark colors that define the older terrains of the planet. It is a reminder that the appearance of this world is shaped not just by our own sun, but by the energetic output of the wider galaxy, tying this distant place to the grand story of the Milky Way. Floating through the outer regions of the solar system is a faint, continuous rain of microscopic space dust, the remnants of ancient comets and collisions within the Kuiper belt. This fine debris slowly settles onto the icy plains of the dwarf planet, acting as a dark tint that should naturally obscure the bright glaciers over time. However, the continuous recycling of the nitrogen ice through sublimation and convection prevents this dust from accumulating on the active plains. Only on the rigid, unchanging water-ice mountains does this cosmic dust find a permanent home, slowly blending with the organic tholins to create the dark shades of the highlands. This process highlights the ongoing struggle between the external environment trying to darken the world and the internal geology working to keep it clean. The underlying bedrock of water ice possesses a high degree of thermal inertia, meaning it retains its deep, stable cold regardless of the seasonal shifts in sunlight. While the soft, volatile surface ices react quickly to the changing distances from the sun, the rigid mountains and deep crust remain entirely unmoved by these superficial fluctuations. This structural stability provides a permanent anchor for the entire planetary system, ensuring that the global geography remains intact across the centuries. The deep crust acts as a giant reservoir of primordial cold, buffering the world against the variable conditions of its elongated orbit. It represents the permanent soul of the planet, an unyielding foundation that outlasts the temporary seasons of gas and frost. By serving as the largest and most well-studied member of the Kuiper belt, this remarkable world provides us with a foundational baseline for understanding thousands of other icy bodies in the outer dark. The complex lessons we learn here about nitrogen convection, organic tholin formation, and satellite system stability apply to countless hidden worlds that we have yet to see up close. It has transformed our view of the outer solar system from a cold graveyard of dead fragments into a vibrant frontier of active, evolving geologies. Every discovery made on this distant sphere echoes across the wider cosmos, illuminating the nature of the dark realms that guard the borders of our solar home. It stands as a brilliant pioneer of the deep dark, a frozen masterpiece that continues to expand our minds and inspire our curiosity. When we examine the distribution of methane ice across this distant world, we observe a fascinating pattern that stands in sharp contrast to the behavior of nitrogen ice. While the heavy nitrogen prefers to pool within the deep lowland basins, methane ice is frequently found perched high upon the mountain ridges and along the rims of ancient craters. This creates a stunning visual effect where the dark, jagged peaks appear to be capped with a brilliant white frost, much like the snow-covered mountains we see on Earth. This preferential accumulation happens because methane undergoes sublimation and condensation at slightly different temperatures, allowing it to migrate easily to higher, colder elevations over time. It reveals a highly complex planetary frost cycle where different volatile gases choose their own unique sanctuaries across the landscape. Observing these frosted peaks helps us appreciate how subtle chemical variations can write completely distinct patterns across the face of a freezing world. Deep within the core of the glowing planetary heart, carbon monoxide ice blends seamlessly with the vast fields of shifting nitrogen. This highly volatile substance possesses a unique spectroscopic signature that allows planetary scientists to map its exact location from billions of kilometers away. It is not distributed evenly across the globe, but is concentrated almost exclusively within the deep, convective basin of Sputnik Planitia. The presence of carbon monoxide slightly alters the physical properties of the surrounding nitrogen ice matrix, making it even softer and more fluid at these extreme cryogenic temperatures. This chemical partnership allows the glaciers to flow with greater structural ease, carving out the perfectly smooth horizons that define the planet's active core. It is a quiet collaboration of elements, working together to maintain the youthful face of the great icy plain. Extending along the equator of the planet is a massive, dark territory known as Cthulhu Macula, which stretches like a giant shadow across thousands of kilometers of terrain. This ancient landscape represents the primordial crust of the world, a place that has remained completely untouched by the rejuvenating forces of recent geological activity. It is heavily scarred by ancient impact craters, whose sharp rims have been softened across the eons by the slow settlement of dark organic hazes. The deep mahogany and charcoal color of this region creates a stark, beautiful boundary where it meets the pristine white ice of the Central Plains. Wandering through this dark wilderness is like reading the very first chapter of the planet's history, preserved perfectly in the cold silence of the equatorial belt. It stands as a monument to deep time, showing us what the world looked like before its icy heart began to beat. At the rugged boundaries, where the water ice highlands meet the smooth nitrogen plains, we can observe intricate systems of glacial valleys that carve deep channels into the bedrock. These valleys are formed by the slow, inexorable flow of solid nitrogen as it drains from the surrounding mountains and enters the massive central basin. The pathways of these frozen rivers are wide and smooth, showcasing the immense mechanical power that even soft, volatile ices can exert when given millions of years to move. Some of these channels feature complex, branching patterns that look remarkably like the river deltas of warmer worlds, though they are entirely dry and locked in an absolute freeze. They stand as a magnificent testament to the universality of fluid dynamics, proving that liquid water is not the only medium capable of sculpting deep networks of valleys into a planet's crust. In the high northern latitudes of this icy world, exploration has revealed a bizarre geological feature that resembles a giant, multi-legged spider stretching across the terrain. This unique formation, known to science as Sleipnir fossa, consists of several deep fractures that radiate outward from a single central point, like cracks in a broken mirror. Geologists believe this striking pattern was created by intense, localized stress within the crust, possibly caused by a plume of fluid material trying to push upward from the deep interior. As the underlying ice expanded or shifted, it forced the rigid surface bedrock to snap along precise geometric lines, creating an intricate network of narrow chasms. This unusual feature adds another layer of mystery to the northern plains, demonstrating that the internal forces of the world can create highly ordered structures in the dark. Far to the east of the Great Heart lies a truly alien landscape known as Tartarus Dross, which features vast fields of towering, blade-like structures made of solid methane ice. These jagged ridges rise hundreds of feet into the thin sky, standing side by side in a mesmerizing pattern that resembles the scales of a giant cosmic serpent. This bladed terrain is unique to the highest elevations of the planet, where methane gas sublimates directly into the vacuum over immense seasonal cycles. The relentless, slow evaporation strips away the softer elements, leaving behind these sharp, resilient ridges that catch the dim light of the sun like shards of broken glass. Walking through this landscape would feel like navigating a maze of frozen swords, a dramatic example of how extreme environments can sculpt the surface into beautiful, terrifying geometries. Within the delicate blue sky, modern instruments have detected the subtle presence of minor hydrocarbons, such as acetylene, ethylene, and ethane dancing, alongside the dominant nitrogen gas. These trace gases are created in the upper atmosphere when ultraviolet sunlight shatters the simple methane molecules, forcing the fragments to recombine into more complex chemical structures. Although they exist in incredibly small quantities, these hydrocarbons play a crucial role in the condensation process that creates the global haze layers. They act as microscopic seeds around which the heavier organic particles can gather and grow before raining down onto the surface below. This complex chemical kitchen, high above the frozen plains, shows us that even a thin, cold atmosphere can host an intricate web of reactions that continuously shapes the world's appearance. The human story of this distant world began in the early 20th century through the tireless efforts of a young astronomer named Clyde Tombaugh working at the Lowell Observatory. Armed with a mechanical device called a blink comparator, he spent countless hours comparing photographic plates of the night sky, searching for a single point of light that moved against the static background of stars. In the winter of 1930, his incredible patience was finally rewarded when he spotted the elusive world drifting silently through the constellation of Gemini. This historic discovery expanded the known boundaries of our solar system significantly capturing the imagination of a global public, fascinated by the mysteries of the dark outer rim. It represents a triumph of human curiosity, a moment where a terrestrial watcher reached out across billions of kilometers to find a hidden needle in the cosmic haystack. The process of naming this newly discovered world took a beautifully poetic turn when an 11-year-old girl named Venetia Burney made a suggestion over breakfast in England. Fascinated by ancient mythology, she realized that a world sitting in the absolute cold and permanent twilight of the outer solar system would be the perfect realm for Pluto, the god of the dark underworld. Her grandfather passed the inspired idea along to prominent astronomers, who found the name to be an absolute masterpiece of thematic and scientific fit. The name was officially adopted, and its first two letters also served as a respectful nod to Percival Lowell, the astronomer who had predicted the planet's existence decades prior. This charming connection between a young girl's imagination and the farthest reaches of space reminds us that science is deeply intertwined with our shared human culture and stories. For 85 years after its initial discovery, this distant world remained nothing more than a blurry, pixelated dot in even the most powerful human telescopes, hiding its true face from our sight. That veil of mystery was finally torn away in July of 2015, when NASA's New Horizons spacecraft completed its historic, high-speed flyby through the system. Traveling at speeds faster than any vehicle before it, the robotic explorer swept past the icy plains, capturing breathtaking images and rich scientific data that stunned the global scientific community. In a single day of intense observation, our understanding of this world was completely revolutionized, transforming a cold dot into a vibrant masterpiece of active geology and complex atmospheres. This incredible feat of engineering brought the edge of the solar system directly into our homes, bridging the immense void with the power of human ingenuity and wonder. The physical proximity of the giant gray companion moon creates a fascinating scenario where the two worlds occasionally seem to share the outermost fringes of their sky. As the thin nitrogen atmosphere expands during the warmer periods of the long orbit, some of the escaping gas drifts directly into the gravitational path of the massive satellite. This interplanetary transfer of material forms a tenuous bridge of molecules hanging in the dark void between the two bodies. It is a rare phenomenon in astrophysics, where a moon actively skims gas from its parent planet, transforming the space between them into a shared chemical arena. This silent, invisible flow reveals that the boundaries of these outer worlds are not completely isolated, but are intimately woven together through gravity and gas. How beautiful it is to imagine these two worlds breathing together across the silent void of space. Over immense stretches of cosmic time, The spin axis of this distant world undergoes dramatic oscillations that radically alter its global climate cycles. Unlike the Earth, which maintains a relatively stable tilt due to the stabilizing presence of our large moon, this outer planet experiences massive shifts in its orientation over millions of years. These profound changes in tilt cause the zones of maximum sunlight to wander across the globe, turning ancient equatorial regions into polar wildernesses and vice versa. During these long eras, the volatile nitrogen and methane ices migrate across thousands of kilometers, completely abandoning old basins to pool in entirely new areas of the crust. This slow planetary wobble acts as a grand climate engine, reshaping the distribution of frost and changing the face of the world in a repetitive, millions of year melody. It shows us that even the climate of the outer edge is never truly static, but follows a grand, slow cycle of movement. Deep within the massive basin of the planet's icy heart, scientists estimate that the smooth nitrogen sheet reaches an incredible thickness of several kilometers. This massive volume of frozen gas represents a colossal reservoir of volatiles, weighing heavily upon the underlying water-ice crust of the world. The immense weight of this deep ice sheet creates enormous pressure at its base, which helps lubricate the slow convective churning of the polygonal cells. It is a staggering thought to realize that this smooth, flat plane is not a thin coat of frost, but a deep, churning ocean of solid gas filling an ancient crater. This deep reservoir ensures that the planet has a nearly inexhaustible supply of nitrogen to fuel its atmosphere and weather cycles across the eons. It acts as the great thermal buffer of the world, preserving the active spirit of the surface across deep time. The overall density of this distant world provides crucial clues about the primordial ingredients that were available at the cold birth of our solar family. Measuring roughly 2 grams per cubic centimeter, its density indicates a composition that is an even mixture of rock and water ice, setting it apart from the purely icy comets of the deep Kuiper belt. This higher rock content explains why the world possesses enough internal radioactive heat to maintain an active geology and a potential subsurface ocean across billions of years. It suggests that during the early formation of the outer solar system, larger bodies were able to gather significant amounts of heavy material before the nebula cleared. By analyzing this density, we are tracing the chemical fingerprint of the ancient disk that once surrounded our young, bright sun. It connects this lonely sentinel to the grand architectural history of all the planets in our system. The surface exhibits some of the most extreme contrasts in brightness found anywhere in the entire solar system, creating a stark visual landscape of light and shadow. The brilliant white glaciers of the central plain reflect nearly all the faint light that strikes them, gleaming with an intense clarity in the permanent twilight. just adjacent to these radiant fields lie the ancient equatorial maculae, which are as dark as charcoal and absorb nearly every ray of sunlight. This intense juxtaposition means the planet is simultaneously one of the brightest and one of the darkest objects in the outer neighborhood. This dramatic variation in reflectivity influences the local microclimates, creating distinct pockets of warmth and cold that drive the slow movement of surface gases. The world is a masterpiece of dynamic contrasts, painted with the simplest elements in the deepest cold. During its historic sweep through the system, the robotic spacecraft conducted intensive searches for any evidence of cosmic rings or hidden dust structures encircling the dwarf planet. Throughout the solar system, giant planets and even some small asteroids possess delicate rings made of debris captured from ancient impacts or shattered moons. However, the space surrounding this icy world was found to be remarkably clean, completely devoid of any rings or dangerous sheets of dust. The powerful gravitational interplay between the planet and its giant companion moon likely clears this region, sweeping away any stray particles or throwing them out into the wider void. This clean environment allowed the spacecraft to pass through safely, confirming that the beauty of this system lies in its moons rather than rings. It leaves the immediate space around the planet completely clear, an open and undisturbed window into the deep dark. Stretching across the high northern latitudes is a vast, distinct geological territory known to science as Lowell Regio, named in honor of the astronomer who sought this world. This polar expanse features a pale yellowish coloration that sets it apart from both the bright white heart and the dark red equator. The unique tint is caused by a high concentration of methane ice that has been slowly processed by cosmic radiation over long periods of time. The terrain here is gently rolling, marked by ancient, degraded craters and wide valleys that indicate a slower pace of geological renewal compared to the active south. It stands as a quiet, frozen frontier, a northern cap that preserves its own unique chemical signature in the dim light of the distant stars. This northern landscape provides a quiet contrast to the churning activity of the heart, showing a different side of the planet's personality. If we focus our attention on the narrow troughs that separate the giant polygonal cells of the great nitrogen plain, we discover a complex network of dark, shifting lines. These troughs are often filled with smaller deposits of dark tholin dust and methane frost that have been swept into the depressions by the gentle winds. Because the nitrogen ice is constantly rising in the center of the cells and sinking at the edges, these borders are zones of continuous mechanical interaction. Small convective plumes and minor fractures form along these boundaries, creating an intricate tapestry that looks like organic tissue when viewed from high orbit. This delicate cellular grid shows that the entire plane behaves like a living fluid, moving to a slow thermodynamic rhythm that keeps the surface eternally young. It is a stunning visual reminder that order can emerge naturally from the simple flow of heat and mass. The extensive system of deep fractures and graben cutting through the ancient crust indicates that the planet has experienced massive structural pulling apart throughout its history. These giant faults run parallel to each other for hundreds of kilometers, creating deep-stepped valleys where large blocks of the water ice bedrock have dropped downward. This global stretching is a clear sign that the world expanded in size as its internal contents underwent phase changes over the eons. As the hidden interior cooled, or as a subterranean liquid ocean began to freeze, the outer crust was forced to accommodate the shifting volume by cracking open. These dramatic chasms reveal the immense structural forces that have shaped the topography, writing the physical autobiography of the world in deep lines across the stone and ice. They stand as silent witnesses to the internal struggles of a small world trying to find its balance in the dark. The long-term survival of this complex system of 5 moons is a marvel of gravitational stability within a highly eccentric and tilted orbit. As the dwarf planet plunges closer to the sun and then retreats into the deep dark, the entire system experiences fluctuating gravitational stresses from the outer giants. Yet the mathematical harmony of the moons ensures that their orbits remain tightly bound and secure across billions of years of cosmic travel. Each small satellite adjusts its path slightly in response to the movements of its neighbors, maintaining a delicate orbital equilibrium that prevents chaos from dismantling the family. It stands as a beautiful testament to the resilience of natural systems, a perfectly balanced clockwork mechanism ticking away in the silent emptiness of the outer rim. This enduring stability wraps the entire planetary neighborhood in a profound, unchanging peace that outlasts the centuries. The profound realization that this icy sphere is not a lonely anomaly, but the true pioneer of a vast outer kingdom reshapes our entire perspective on the solar system's architecture. As the archetype of the Plutoids, it represents an immense family of hidden worlds that inhabit the frozen stretches of the Kuiper belt. These distant bodies possess enough mass to form perfect spheres under their own gravity, yet they exist in a delicate balance with the surrounding cosmic debris. By studying the intricate details of its surface, scientists are actually deciphering the common characteristics of thousands of undiscovered worlds drifting in the deep dark. It stands as a proud representative of a hidden planetary population, a testament to the fact that the outer edge of our neighborhood is teeming with quiet activity. This shift in definition elevates its status, turning it into a crucial key that unlocks the mysteries of the farthest reaches of space. The discovery of vast, regular dune fields sweeping across the margins of the Great Nitrogen Plain provides undeniable evidence of active atmospheric processes on a world once thought to be completely static. These beautiful ripples are not composed of silicate sand like the deserts of Earth or Mars, but are formed from microscopic grains of solid methane ice. The gentle, persistent winds blowing off the nearby water ice mountains possess just enough force to lift these frozen particles and arrange them into perfect geometric patterns. This mesmerizing landscape demonstrates that even an atmosphere thinner than a whisper can act as a powerful mechanical sculptor over immense periods of time. It challenges our understanding of wind-driven geology, proving that dunes can form in the absolute cold if the materials are light and volatile enough to respond to the air. The long, repeating lines of these methane dunes create a stunning texture on the plains, a quiet manifestation of a global weather system working in absolute serenity. The continuous warmth required to power the planet's active geology and maintain its hidden internal ocean is generated by the slow, steady decay of radioactive elements deep within its rocky core. This primordial heat source has been quietly operating for over 4 billion years, counteracting the intense chill of the outer space environment from the inside out. Unlike the moons of the giant outer planets, which are warmed by the violent pulling forces of gravitational tides, this dwarf planet relies entirely on its own internal radioactive reserves. This independent energy budget allows the rocky core to act as a permanent thermal engine, slowly warming the overlying water ice mantle and driving the convection of the nitrogen glaciers above. It represents a beautiful balance of nuclear physics and planetary geology, showing that a world can store its own creative energy across deep cosmic eons. We look upon this quiet world and realize that its frozen exterior is sustained by a warm, radioactive heart that refuses to go cold. The diverse color palette that paints the surface of this distant world serves as an eloquent timeline, revealing the exact age and history of each distinct geological region. The ancient equatorial zones, heavily coated in a thick layer of dark crimson tholins, represent terrains that have remained undisturbed since the early days of the solar system. In contrast, the brilliant white and pale pink fields of the northern plains indicate areas where fresh volatile frost has recently settled, covering the older scars of time. By reading these color variations, planetary scientists can map out the historical chapters of the planet, identifying which landscapes are ancient archives and which are youthful creations. This visual harmony shows that the surface is a dynamic canvas where chemistry and time blend together to tell a story of continuous transformation. The shifting hues from dark charcoal to brilliant pearl create a stunning global mosaic, a silent record of a world that remembers its past while constantly reinventing its present. the powerful gravitational partnership between the dwarf planet and its giant companion moon ensures that their immediate orbital environment remains remarkably clean and free of cosmic debris. As the two massive bodies revolve around their shared center of mass, their combined gravity acts as a celestial broom, sweeping away any stray dust or small fragments left behind by passing comets. Any material that attempts to settle into a ring system or a cloud around the binary pair is quickly destabilized and thrown out into the wider void of the Kuiper belt. This ongoing gravitational cleanup explains why modern spacecraft found no dangerous dust sheets or hidden rings during their historic passage through the system. It creates a pristine sanctuary in the deep dark, a zone of perfect orbital clarity where the 5 moons can navigate their paths without any risk of collision. This clean space highlights the profound order that a binary planet system can establish, wrapping the entire neighborhood in a secure, undisturbed peace. The presence of massive cryovolcanic mountains like Right Mons completely redefines our understanding of volcanic activity across the wider universe, proving that fire is not the only force capable of shaping a planet. In the extreme cold of the outer solar system, ice behaves exactly like rock, and liquid water mixed with ammonia becomes the functional equivalent of molten lava. When this freezing slurry erupts from the deep interior, it flows in thick, viscous waves that solidify into giant domes and undulating hills rather than evaporating into space. This quiet, cold volcanism reveals that the internal layers of the planet have retained a surprising level of mobility and fluid activity long after traditional models predicted they should have frozen solid. It shows us that nature can achieve the grand structures of volcanism using entirely different ingredients, adapting the laws of thermodynamics to the absolute freeze of the outer rim. These giant ice volcanoes stand as monuments to the unexpected versatility of water, carving out a unique legacy in the permanent twilight. The prospect of returning to this distant world with future robotic exploration missions presents an extraordinary technological challenge that pushes the boundaries of human ingenuity and space engineering. Because the planet possesses such a weak gravitational pull and sits at the end of a multi-billion kilometer journey, a traditional spacecraft arriving at high speeds would simply fly past without being able to slow down into a permanent orbit. To successfully capture an orbiter or deliver a lander to the nitrogen glaciers, future engineers must develop advanced nuclear propulsion systems capable of firing continuous, gentle thrust over many years. Such a mission would allow us to witness the slow changing of the seasons across decades, monitoring the majestic breathing of the atmosphere and the churning of the polygonal cells up close. It represents the next grand frontier of outer solar system exploration, a dream of establishing a permanent human eye at the very edge of the sun's domain. Until that day comes, the data we possess remains a treasured archive, a faint glimpse of a world waiting quietly for our eventual return. The critical chemical ingredient that allows the hidden subterranean ocean to remain liquid in an environment of absolute cold is the subtle presence of ammonia dissolved within the water. Ammonia acts as a highly efficient natural antifreeze, significantly lowering the freezing point of water and allowing it to remain fluid even at temperatures far below its normal limits. This chemical compound also reduces the density of the liquid slurry, helping it remain buoyant and rise through the fractures of the water ice crust to power the cryovolcanic mountains above. The interaction between ammonia, water, and the rocky core creates a complex chemical laboratory deep beneath the frozen plains, a realm where liquid dynamics can persist across deep time. This realization expands our definition of where liquid oceans can exist in the universe, showing that habitable environments do not require the direct warmth of a nearby star. It suggests that the dark interiors of icy dwarf planets may be some of the most common reservoirs of liquid water in the entire cosmos. Looking forward into the incredibly distant future of our solar system, this cold and lonely world is destined to experience a dramatic and beautiful transformation when our sun reaches the end of its life. Billions of years from now, the parent star will expand into a colossal red giant, swelling in size and increasing its energy output by thousands of times compared to its current state. As the inner planets are swallowed by the expanding star, the zone of warmth will shift dramatically outward, bathing the frozen plains of the Kuiper belt in a brilliant, intense light. During this brief cosmic autumn, the nitrogen glaciers will completely melt. The thin atmosphere will thicken into a heavy sky, and the dwarf planet may temporarily transform into a warm ocean world. This twilight summer will mark a magnificent finale for the system, a moment where the cold sentinel finally steps into the warmth before the entire solar family fades into the eternal dark. It reminds us that all structures in the universe are temporary, moving through grand cycles of ice and fire across the eons. As we complete our detailed survey of this remarkable planetary system, we recognize that this distant world serves as an absolutely pristine archive of the original nebula that birthed our solar family. Locked within its deep layers of water ice and preserved on its frozen nitrogen plains are the primordial chemical ingredients that have remained unchanged for over 4 billion years. By studying this remote sphere, we are not just observing a distant planet, but looking directly backward in time to the very dawn of creation, reading the untouched foundations of our cosmic home. It sits at the edge of the infinite dark, like a beautifully preserved time capsule, holding the secrets of how matter first gathered to form the worlds we know today. Its quiet existence reminds us that the answers to our deepest questions about our origins are often hidden in the coldest, most isolated corners of the universe. It remains a silent monument to deep time, an elegant masterpiece of ice and stone guarding the ancient frontier of our celestial home. Our drifting journey now carries us slowly away from this magnificent double world, leaving the frozen heart and its family of tumbling moons to continue their silent voyage through the dark. Looking back one last time, we see the fragile blue ring of the atmosphere fading into the stellar background, a thin veil of gas guarding a world of unexpected activity and beauty. The vast fields of Sputnik Planitia continue their slow, convective breathing in the permanent twilight. An endless cycle of creation, powered by a warm, radioactive core, hidden deep beneath the unyielding water-ice bedrock. We watch the dark slopes of Cthulhu Macula and the frosted peaks of the mountains slip back into the long equatorial shadows, preserving their organic secrets in the absolute cold. We leave this lonely sentinel exactly as we found it, moving along its tilted, elongated path around a sun that is now nothing more than a bright, distant diamond. It remains a proud pioneer of the outer kingdom, a pristine time capsule that preserves the ancient history of our celestial family for the eons to come. How remarkable it is to reflect on the wonderful complexity that nature can forge at the absolute limits of cold and isolation. This world teaches us that even in the deepest freeze, the spirit of geological activity can endure, shaping majestic mountains, carving glacial valleys, and maintaining hidden liquid oceans far from any traditional source of heat. It challenges our human perceptions of time and scale, reminding us that the universe operates on a grand, patient clock that requires no human audience to maintain its perfect, clockwork harmony. The intricate waltz of Charon and the chaotic tumbling of the smaller satellites show us a cosmos that is beautifully organized, yet full of delightful, unpredictable irregularities. By understanding this remote sphere, we have expanded the boundaries of our own minds, reaching out across billions of kilometers to find meaning in the quiet places of the universe. We find a deep sense of comfort in this enduring stability, knowing that these icy worlds will continue their peaceful dance across the centuries, completely undisturbed by the fleeting moments of our own lives. As the distant sphere shrinks back into a tiny point of light against the infinite black canvas of the Kuiper belt, the profound silence of the outer rim wraps around us completely. The heavy lines of the tectonic canyons, the sharp blades of the methane dunes, and the giant cryovolcanic peaks dissolve into the gentle shadows of the cosmic deep, leaving behind a profound sense of stillness and wonder. The cold twilight of the edge gives way to an absolute, resting dark, a vast emptiness that is both gentle and protective. We return our thoughts to the familiar quiet of our own resting space, carrying the calm rhythms of the nitrogen glaciers and the serene peace of the binary dance within our minds. The great cosmic ocean continues its slow, majestic flow, inviting us to release the remaining tension of the day and settle into the absolute peace of the universe. Sleep safely now in the quiet custody of the stars, drifting peacefully through the endless dark as our long journey comes to a restful, beautiful close.